In this video, we're going to go over some properties of the normal distributions and how we can use normal distributions to calculate some probabilities. All right, so quick properties of normal distributions. Normal distributions are symmetric about the mean and they're unimodal. So often when we talk about normal distributions, we talk about something known as the bell curve. I don't know if you heard of that before, but the bell curve is simply if this was a like, let's say this is a timeline of a number line of all my data values as we go from negative infinity to positive infinity. A distribution of my data values, if they look like this, that bell curve where it's unimodal and symmetric. And remember, so just think of this as being kind of like a, like a curve that kind of mimics the height of these histogram bars, all right? If they're unimodal and symmetric, then we say it's a normal distribution. All right. The center of a normal distribution is the mean, whereas the standard deviation determines in how wide the normal distribution can be. So if you'll allow me here, let me come down to the bottom. Let me show you what it does. So let's say we have, once again, all of our x values going from negative infinity to positive infinity. And let me draw a couple of normal curves here. Let's say I have a normal curve. It does something like this. And the tails of these normal curves, they extend forever. Okay, they just get closer and closer to the horizontal axis, but they don't cross. So let's say that's one, and then let's say we have another normal curve. Actually, let me draw that a little better. Let's say we have another normal curve that does something like this. Okay. All right, so what we have here in the red and the green are two separate normal curves. Well, how do we know the difference between them? Well, the center of the distribution, right, just go to the peak, right? Go to the peak, that's the center of your distribution. That's the mean. So as we look at these, since the mean of the red curve is farther left on that number line, that means that the mean of the red curve is smaller. So the mean of the red curve is less than the mean of the green curve because its center, where it lies on that number line, is farther to the left on that number line. The standard deviation measures the width of that curve, right? So imagine like a scrunchie or a rubber band or something. As I tug on that scrunchie and rubber band, it's going to stretch apart, but it's going to become shorter. So the larger my standard deviation, the shorter my distribution becomes, or shorter and wider it becomes. The smaller my distribution, the more tightly packed the data values are, so it becomes skinnier and taller. So the standard deviation of the red curve is going to be greater than the standard deviation of the green curve. If I could ever learn how to spell green. Okay, so I hope that's just a quick little illustration of what the mean and standard deviation do to a normal curve. All right, back to our properties. The area under the normal curve was 1. So it will always be 1, and that's very important. We're going to use that fact whenever we get to calculating probabilities. And then there's this thing called an empirical rule. It's basically just a rule of thumb. It says that if you have a normal distribution, or approximately normal, about 68% of the data is going to lie within one standard deviation. So you go to the center of the mean. If I go one standard deviation to the left, one standard deviation to the right, that swath of area, that swath of data values, it's about 60% of all my data values. If I go 2 standard deviations to the left and right of the mean, I'm going to get about 95% of my data. And if I go 3 standard deviations to the left and right of the mean, I have about 99% of my data. So I have about all my data within 3 standard deviations when the distribution is normal. So that's why if you ever heard the phrase that if you're more than 3 standard deviations away from the mean, you're an outlier, aka a weird value, that's where that came from. All right, but there's all types of normal distributions out there, but a really particular one, the rock star of all the normal distributions, is called the standard normal distribution. And what that is if we have a distribution of z-scores, right? Remember we talked about that in the previous video. If I have a standard deviation of, a distribution of z-scores, I have what's known as the standard normal distribution. And it's known as the z distribution. So Whenever you're dealing with the z-distribution, z-scores, your mean will be 0 and your standard deviation will be 1 by default, automatically. All right, let's get into a few examples to see how we can use this information regarding the normal distribution. So first of all, what I have here is, for example, we have a couple of histograms, and we want to indicate if these histograms give us normal distributions or not. All right, let's look at that first histogram here. We'll notice here that if we were to kind of draw a curve right around that histogram there, you notice that it is not unimodal, right? There's not just one peak in this curve that we drew here. For that reason, this is not a normal distribution. Okay, now it is symmetric. It is pretty symmetric, but it is not unimodal. All right, so not a normal distribution. However, the second example here of a histogram, if we were to kind of draw a curve here that follows the heights of those, that's relatively symmetric and it's unimodal. Therefore, yes, this particular histogram is indicative of a normal distribution. So that is a normal distribution. So the first one is not, but the second one is a normal distribution. Okay, moving on. Suppose that we have a data set and it's approximately normal. So we just said that means the histogram is symmetric and unimodal. The mean of this data set is 40 with the standard deviation of 2.5. Draw the normal model using that empirical rule of thumb that 68% of the data is within 1 standard deviation, 95 is within 2 standard deviations, and 99.7 is within 3 standard deviations. Okay, so in order to do that, let's draw this out here. So I have my horizontal axis there, okay? And what I'm going to do is, since it's a normal distribution, I'm going to draw my normal curve. Here, let's do it in black, my normal curve. All right, it's that bell shape or mound shape distribution. And these tails, remember, they extend infinitely on. So does my number line. So sorry how that's looking. And I like to do this right down the middle. Okay, what value is that? Remember, we say the center of a normal distribution is the mean. The mean of this data set is 40, so that means that value right down the middle, where that peak of that mound is, it's going to be 40. Okay, so 68% of my data lies within 1 standard deviation, and the standard deviation is 2.5. So that means, let's go a different color here. If I go to 40, and I subtract away 2.5, that will give me 1 standard deviation to the left. So if I do 40 minus, let me do a different color here. Yeah, 40 minus 2.5, that gives me a 37.5. Okay? Once again, if you need a reminder there, that was 40 minus 2.5. All right, let's draw, let's do a dotted line here. Okay, I'm gonna do the same thing. I'm gonna add 2.5 to 40. So that'll be here, that'll be 42.5. Okay, that dotted line here. So what we are saying is that between those two blue dotted lines, 68% of our data will be between 37.5 and 42.5. That's what it means to be within 1 standard deviation. Now, let's do it for 95%. 95% says you need to go 2 standard deviations to the left and right of the mean. Is that in a different color? Well, either I can say 2.5 times 2, which is 5. I could do 40 minus 5, or I could just simply take another 2.5 away from my 37.5. Whichever way that you look at it, this value right here should be a 35. Okay, and in the same fashion, if I take 42.5, add another standard deviation of 2.5 to it, I get 45. So now between those two green lines, right, I'm going to have 95% of my data between those. All right, and then lastly is 99.7. We just tack on another 2.5 to our last value here. And let's do that in, guess this color, blue. So if I come here, if I take 45 plus 2.5, that's 47.5. If I subtract away 2.5 from 35, I get 32.5. And now between these blue lines, I have 99.7% of my data. All right. So that's what they mean whenever they say, you know, draw the normal model. All right, let's move on. So since the total area under the normal curve is 1, we can use the area under the curve's probabilities. All right, so the following examples will show you exactly how to do this, and I'm going to use this. I'm going to do this using Statcrunch, which is built into our homeworks platform. If you want to know how to use this in a calculator, feel free to send me an email or stop by my office hours. But let's say we wanted to find the area to the right of a z-score equals negative 1.25. So we want to find the area to the right of a z-score of 1.25, negative 1.25. All right. And stats is always helpful to draw a picture, so we'll do exactly that. So we have our normal curve. So when we talk about z-scores, we're talking about normal curves. Let's draw that a little better. Okay. There we go. All right. If you remember, for z-scores, remember what we said about the z distribution? We said the mean, and let me give you guys some symbols here. The mean we use is, the symbol is mu. That's the symbol that we use a lot. The mean is equal to 0, and the standard deviation, which is the Greek letter sigma, is equal to 1. So if I want to kind of do what we did in the previous example here, just a little bit of it, my mean, and this is our horizontal axis represents all possible z-scores. Right down the middle is where my z-score equals 0, because that is the mean of the z distribution. Now I want to find the area to the right of a negative 1.25. So a negative 1.25 is to the left of my z-score. And let's go ahead and call this a negative 1.25. And I want to find all this area that's all the way to the left of all that area to the left. Okay? So how can we do that? Well, we can use something called z-tables, where mathematicians and statisticians went ahead and calculated all these various areas for us, or we can just use our Statcrunch. So let me show you how to do this in Statcrunch. Okay, if you're in Statcrunch, or excuse me, if you're in your homework system and you want to know how to get to Statcrunch, if you look at the bottom of my screen here, there's a Get More Help button, and then there is a Statcrunch option. So that's how you get to Statcrunch if it's not readily available for you. All right, so how do we get to calculating the area with these normal distributions? Well, what you're going to do is, let me see here. You're going to hit your stat button. So up at the top, you'll see Statcrunch, Applets, Edit, Data, Stat. We're going to hit Stat, and we're going to select Calculators. And what calculator do we want? We are dealing with the normal distribution. So you're going to select the normal calculator. And it brings up this screen here. All right. And so let me go back to our question at hand here. So we want to find the area to the right of a negative 1.25. Let me give you some notation here. What this is saying is, as I told you before, areas are going to be the same thing for probabilities when we do normal distributions. So big P means probability. We want to find the probability that we select a z-score that is to the right or more than a negative 1.25. That's what we need to calculate. If I want to find an area to the right, just look at where my inequality is pointing. My inequality is pointing to the right. If I wanted to find an area to the left, my inequality would be a less than. And I'll show you the case in a second when you want to go in between two values, but hopefully that makes sense. So now what we do is, if you go down to the bottom of our calculator, they need to know what's the mean of your normal distribution. Well, our mean is 0 because we are dealing with the z distribution. And our standard deviation is 1. So we are good there. However, we need to, let me see if I can pull up my calculator here, my keyboard. And what we need to do here, though, is tell them that, hey, we don't want to find the probability that x is less than or equal to 0, but we said we want to go to the right. So what you do is you tap your inequality, and you can see that you're able to select a greater than or equal to. Let me go back really quickly. You notice how they have a greater than or equal to instead of just a greater than? Let me make this really clear. For normal distributions, okay? And matter of fact, any continuous distribution, if you go on to other stats, greater than and greater than or equal to will be the same thing. Okay? And the same can be true about less than. Less than and less than or equal to, they'll be the same thing. Okay? So don't get caught up on whether it's an equals to or not. Just get caught up on the direction that you want to go. That's the most important bit. All right. So we're going to select a greater than or equal to because we want to go to the right. And then we're going to type in, hopefully, keyboard, a negative 1.25. Okay, then we're going to hit compute. And boom. You'll see, first of all, the Statcrunch gives us a picture of what we're trying to calculate. And then at the bottom to the right, you can see that we get a value of a 0.894. 0.894. So this equals 0.894. So another way of looking at that is saying that 89.4% of z-scores are greater than a negative 1.25. So that's how you interpret that area as being a probability. All right, so all you do is you go to Statcrunch, you put in your mean and your standard deviation, and you select the correct direction that you want to go, whether it's left or right. Okay, moving on, let's see here. What percent of z-scores lie between a negative 0.59 and a 1.05? Let's quickly draw that picture. Once again, right down the middle, that's where z equals 0. That's our mean. And we're going to have a negative 0.59, which may be somewhere over here. And we're going to have a 1.05, which may be somewhere over here. And what we're interested in is that area between those two values. Well, how do we figure that out? We go to Statcrunch. So I'm back in Statcrunch. And notice in the top left of my window here, you see where it says normal calculator? And it says standard in between. So standard is when you want to go to just the left or the right. Between is when you need to go, obviously, between two different values. And that's what we need to do here. So once again, our mean is still 0. Our standard deviation is 1. But now our lower value here, let's do keyboard, is going to be a negative 0.59. And our upper bound here, our upper value, is going to be a positive 1.05. Positive 1.05. All right, you're going to put those in compute, and there we go. We get a 57 or 0.576 if we round that to 3 decimal places. 0.576. All right, so let's use our notation here. So the probability that our z-score is between a negative 0.59 and a 1.05, we just said that that equals a 0.576. So there's a 57.6% chance that we get a z-score that's between those two values. All right, just a few more examples here. For example, suppose the heights of high school age males are normally distributed with the mean of 72 inches and a standard deviation of 4.5 inches. Find the probability that a high school male is shorter than 64 inches. Okay. So what we have here is a normal distribution, but it's not the z distribution. So there's actually two ways we could go about doing this. What we could do is, let's do this. There's two approaches. Approach one says convert the data value to a z-score. Then find the probability. All right, so check out the last video on how we can calculate z-scores. Approach two is quicker. Approach two says, don't worry about the z-score. Just go ahead and type in your information into the Statcrunch. Okay, so approach two says find the probability without calculating the z-score. And that's what I'm going to do. I'm going to do approach two. I'm going to show you how to do this without using without calculating the z-score first. Now, it will be a great practice for you to see if you can get the same answer. Both approaches should give you the same answer. So maybe I'll leave that for practice for you guys. I want you to practice this approach. Okay. What I mean by that is step one is find the z-score. And then step two is find the probability. Okay, but remember, the mean is equal to 0 because you have z-scores now, and the standard deviation is going to equal 1 when you use that approach, okay? But for this approach, what we're going to do, the second approach, which I'll do now, is we need to find, let's write it out, and just use our symbols. We need to find the probability that a high school male is shorter than 64 inches. Now, I'm going to use the letter X instead of Z. Why is that? Because this is not a z-score, right? We have a normal distribution, but it's not the z distribution. So I'm going to use X instead. We need to find the probability that a male is shorter than 64 inches. So that means less than 64. Okay? And they tell us that the mean is equal to 72. And the standard deviation is equal to 4.5. All right, so let's use that information. Let's go to Statcrunch. Okay, so I'm going to show you once again how to get to this calculator. You hit your Stat button. Under Calculators, you're going to select Normal. We are going to do the standard option because we're either going to the left or to the right. In fact, we are going to the left. Our mean is, let me double check, our mean is 72. Okay, let's make that look nice. Our mean is 72. Our standard deviation is 4.5. Okay, let's go ahead and hit compute. Oh, I'm sorry. And then we need to change this value, right? We're trying to find the probability that X is less than or equal to 64. Sorry about that. So I know you can't see it, but at the bottom I need to type in a 64. Okay, so at the bottom, I typed in 64, and that's what you're seeing there. Let me just make it a little better here. We're going to type in 64. Oh, no. It's hard to do this on the iPad. I'm sorry, folks. Let me clear all that out. Type in 64. And there we go. All right, so to 3 decimal places, I know it's really hard. Can I zoom in? There we go. I know it's hard to see, but to 3 decimal places, it's a 0.038. 0.038. So if we go back here, our answer is 0.038. So what's the probability? The probability is that there is a 3.8% chance that a high school male is shorter than 64 inches. All right, last part. So up to now we've discussed, okay, if I know the z-score, if I know the data value, I know how to get the area, the probability. But what about going in reverse? What if I know the area? How do I get back to that score, right? And so that's what this example is going to show you here. Using the information in the previous example, what is the cutoff for the highest 10% of heights? Okay. So if you remember, and then the second part says what's the cutoff for the lowest 20% of heights? If you remember, we said that our mean was, I believe it was 72, and the standard deviation was 4.5. Okay. Listen, draw a picture. When in doubt, draw a picture. We have a normal distribution. The center of that is the mean, and that's going to be, these are x values, not really z values. The mean is going to be 72, okay? And we want to know what's the cutoff for the highest 10%. So anytime you're in the top 10%, that means you're far right on that number line. So the top 10% is going to be somewhere over here. The problem is I don't know what that height is, but I know if it's the top 10%, I know that this area that I'm shading to the right of it, I know this area is 10%, which I'm going to write as a decimal. I know that area is 0.10, right? So here's the trick on how you're going to do this one. What we're going to do is we are going to do the z-score approach. And what we're going to do is we're going to figure out, first of all, what z-score has an area to the right of it of 10%. That's what we have to find out. And this is how we're going to do it. So first we note that if my area to the right is 10% or 0.10, then my area to the left of that value, so all this area here, my area to the left is 0.90. Is 0.90, okay? Because remember, there's 100% or 1 total area underneath that curve. If there's 10% to the right, that means there's 90% to the left. It has to add up to 100% or to 1 if you write your percents as decimals, okay? The reason why I'm converting these areas to left areas is because we got to go old school. There's not a way to do this with, at least with Statcrunch. There is a way in the calculator. But anyways, we're going to look at some z-tables. And so what I'll do is I'll upload some z-tables to Canvas for you guys. But what I did here is I grabbed a z-table. And first of all, the way that you read this z-table is that you have, so your z-scores, let me go up here. So your z-scores can be negative or positive, right? When you grab so the column, the first column, a negative 3.9, for instance. If I wanted to know the area to the left, so all of these areas in the table, the 5-digit numbers, I believe, the 5-digit numbers that you see, those are areas to the left of a z-score. If I wanted to find the area to the left of a negative 3.90, what I do is I go to where my z-score is a negative 3.9, and then I go to the 0.00 column. So the column tells you the second decimal place. For instance, the area to the left of a negative 3.72, negative 3.72, so I go down to the negative 3.7 row, and then I go over to the 0.02 column. You should get a 0.00010. So once again, these are all areas to the left. And the same thing for the positive values. They give you areas to the left. So, but our situation is different. We don't know the z-score in this case, but we know that the area to the left is 0.90. Okay? So the question becomes, what z-score has an area to the left of 90%, or if we want to write it as a decimal 0.90. This is also called the 90th percentile. So what I'm showing you here is how to find a percentile also. But anyways, what we do is we go to our table. Remember, the area is a 0.90, so we're looking for the 5-digit number that's as close to a 0.90 as possible. And so I know it's going to take a minute for your eyes to adjust, but the closest I see to a 0.90 appears to be this 0.89973. Okay? So that appears to be the closest to a 0.90. The 0.90147 is just a little bit more than 0.90, which is fine, but it's further away from 0.90 than the 0.89973. So now we need to back out what that z-score is. That z-score is a positive 1.28. So the z-score is a positive 1.28. Okay, but that's not our answer. That's our z-score. That's that's not the actual height. So how do we figure out the height? Well, we're going to go back and use our z-score formula. Remember, your z-score is your data value minus the mean over the standard deviation. What I know so far is I just found the z-score that goes with the 90th percentile height, that top 10% height. I know the mean and I know the standard deviation. What I don't know is the data value. So what we're going to do is we're going to solve that equation for x. And the way we do that is we multiply both sides of our equation by the standard deviation. Okay, so on the left side is sigma times z, which I can also rewrite as z times my sigma. Order of multiplication doesn't matter. Right side cancels. I'm left with x minus the mean. I add the mean to both sides, and there is my formula. The mean plus my z-score times my standard deviation gives me my data value. So for us, remember our mean was 72. So we do 72 plus 1.28, that was the z-score that we found, times the standard deviation of 4.5. And that will be the height that represents the cutoff for the top 10%. Okay, so I'm going to do that here. I'm going to do 72 plus 1.28 times 4.5. Orders of operations will work just fine there. And we get 77.76. All right, so the height that represents the cutoff for the top 10% is 77.6 inches. Okay. Really quickly, how do we do it for the lower 20%? Very similar. I'm going to quickly go through this one. Remember, we are centered at 72 inches. Okay, I want the lower 20%. So lower 20% is somewhere over here. Okay, I don't know what that data value is, but I know the area to the left, since this is the cutoff for lower 20%, I know that shaded area is 0.20. And notice it's already the left area. And remember, our table needs left area, so we are good to go. Now we are able to find the z-score. So the z-score that corresponds to that, we go to our table. We try to get as close to 0.20 as we can. So that's going to be in the negatives. If you're less than 50%, you're going to be over the negative side. I'm going to quickly try to find this for you guys. It looks like that 0.2, oh no, that's 2%. We want 20%. Here we go, looks like this, the 0.20045. That's about as close as we're going to get to 0.20. So we back out, what's that z-score? It's a negative 0.84. Negative 0.84. So the z-score is a negative 0.84. And we're just going to use the same formula that we did before. We know the data value when we convert it, so we're converting it back to its original data set. It's going to be x plus the z-score times the standard deviation. Or excuse me, it's going to be the mean. Sorry about that. This should be the mean. So our mean is 72 plus a negative 0.84 times that standard deviation of 4.5. Let's put that in the calculator. 72 plus parentheses a negative 0.84 times 4.5. All right, we do that and we get 68.22. All right, so I know that was a bit of a longer video, but I hope that helps you guys understand the concepts of a normal distribution.